Board. So today, we're going to go through the long answer of practice test 3. You've got test 3 on Tuesday, right? So we're going to be ready. I'm going to go all tough nurse on you guys. You guys heard that? Anyways, like, you will not be allowed to leave the room during the test. I know, inhumane. I can hold it, you can hold it. So, no leaving the room for any reason during the test. If you leave, you will not be allowed back in. I know, mean. That's just how it's gonna be. All right. For the final and for the test. Thank you. November 21. Okay, so I'll start off with that. If you leave the room, during the test, I'll say and final exam. Hey, too chatty back there. And final exam. You will not be permitted back in. Lots of other profs do that, and I used to think that's so mean. But with everyone running to the bathroom all the time, it's just... You will survive. All right, so the practice test, let's do it. So practice test number 3. Long answer solutions. I'll scoot this over a bit. There. All right. I guess before we start, from the practice test, right, you'll see that there's slots for all these calculator inputs. Absolutely, you could do all these by hand. You've got the power, but maybe you don't have the time, right? So you'll want to be able to do all these in your calculator, or at least be able to fill in what your calculator inputs are. And so each of these questions is going to be worth 2 marks, these short answers. If you haven't been able to solve it, but you've put in what all the calculator inputs are correctly, that's 1.5 out of 2 marks. Okay, so even if you find that, okay, I don't have time to do these calculations, even on your calculator, right? At least if you fill in all these slots correctly, that's 1.5 marks out of 2, right? Even without finding the final answer. So that's pretty good. So I'll just make a note here. Each short answer is worth 2 marks. And filling in the correct calculator values and filling in the oh, sorry, got sloppy even here. And filling in the correct calculator values is worth 1.5 marks, even if you don't have time to find the final answer. Just like with test 2, right? I don't want you to start with the short answers. I want you to focus on the long answers. That's where the majority of the marks are, right? Really get those long answers down and then do as much as you can of the short answers. You will have time, but just in case you're running out of time, right? It's better to do the long answers and then come back to the short answers, right? Okay. Any questions before we start? No, start already. All right. Okay, so for the long answers, one, two, three. I'll put a little comma in there, otherwise it's hard to read. Jim purchases a mortgage with a $60,000 down payment. He pays end of the month payments of $2,000 for 25 years. If the interest rate is 4% compounded quarterly, what was the original value of his mortgage? Okay. And then I'm gonna add what's the value of the home, right, which is gonna be slightly different. What is the value of the home? Add that in there. Forgot to add it in. Okay. So we can start with, okay, our compoundings per year. Oops. Our compoundings per year. If you wanted to start with your timeline, that's totally fine, right? But I'm just gonna highlight that our compoundings per year is 4 and we're paying monthly. So our compoundings per year is 4 and our payments per year are 12. Right? And so because these are not the same, we have to find I2. Notice, right, that we have to do all calculations without using the TVM functions on your calculator. So this one you have to do by hand, right? The rest of them, they're not going to specify anything like that, so you can absolutely go ahead and just use your calculator, right? But for this one, you have to show me that you know how to do it by hand. So here we go. The compoundings per year is going to be our F1 and our payments per year is our F2. And that's always the case. And so since F1 is not equal to F2, we need to find I2, which means we first have to find I1. I1 is R1 over F1, which is 4%, so 0.04 divided by 4, which is 0.01. I2 is on your formula sheet, and it's just 1 plus I1 to the power of F1 over F2 minus 1. But maybe you have them all up here. Pardon? Yeah. I use R because it's F1, but it's just R, the 0.04. Is that the one you mean? Yeah. Yeah. Okay. So now we've got 1 plus 0.01 to the power of F1, which is 4, over F2, which is 12, and then minus 1. 1.01 to the power of 4 divided by 12 minus 1. I2 is 0.0033222284, which I'm going to store in 1. 1 or 2 or wherever you want to store it is fine. But I'm going to store it in 1. Make sure I actually did it. Okay, so now let's have a look at the timeline to see what we're solving for, right? But because we're solving by hand, we know we have to find I2 first. So if we start today, and so he gets a mortgage with a $60,000 down payment. He's paying end of the month payments for 25 years. So monthly payments for 25 years means that there's 300 payments. So we end here at 300 months, which is the 25-year mark. But because our payments are monthly, our ticks are going to be monthly. And so same as always for these annuities, right? I want to see the first 3 ticks, so 1 month, 2 months, ... and then the last 2 ticks, 299 months. And he's making payments of $200 at the end, because we introduced annuities due, which are payments at the beginning, right? So that's going to change our formula a little bit. But these are at the end of the month, but it could just as well be at the beginning, right? Or other way, I guess, right? But these are at the end, and they're $2,000 all the way through. A mortgage is a loan, right? So the value of a loan is always a present value, right? We're always pulling it back to a present value. So these guys funnel back to a present value. This present value, I'll just make a note, right? That's the total value of the mortgage, right? Or the original value of the mortgage. Now, if you read that as the total value of the home, then that's great, right? I wouldn't even consider that a mistake, because that's doing more work than I asked for, right? But the present value is the value of the mortgage. And then we said, okay, well, he makes a $60,000 down payment, right? And so that's a payment that happens today. So 60,000, those two added up, that's the total value of the home. The total value of the home. All right. So we need to find the present value. We know that N is the number of payments. We already found it, right? It's time times the frequency, or sorry, F2, which is going to be 25 times 12, which is 300. It's less important to put the N on the arrow for annuities because we'll already have them up top, right? But you have to have your N somewhere, so may as well be on your arrow. I don't know. Okay. Now we can calculate the present value. This formula I have not memorized quite yet. Yeah, we'll get there. We need to find the present value is the PMT, the payment amount, times 1 minus 1 plus I to the negative n over I. This payment amount is $2,000 times 1 minus 1 plus, and I'm going to cheat here because we have to use I2, which is stored in 1, so I'm just going to write recall 1, right? So I'm not having to write this out over and over and over again. So I'm going to write recall 1 to the negative 300 all over recall 1. There's brackets inside our brackets, so that's where we have to start. We have to figure out what's inside the brackets, and then we kind of bloom out, right? And so we do 1 plus recall 1 to the power of 300 negative, and then 1 minus that guy divided by recall 1. I do not expect to see these steps written out. If you just go straight to the answer, that's fine. Otherwise, it would be it would just take way too long, right? And so for these calculations, it's just easier to just do it on your calculator and get to the end, right? So times 2,000, I get 379,431.0628. So the present value in money, let me just make sure that that's actually what I got. Yeah, is 379,431 and 6 pennies. This is the total value of the mortgage. So the total value of the home is PV plus 60,000, 379, 431.06 plus 60,000. $439,431.06. What are some ways that the structure of this could change while the payments could be at the beginning? Right, totally reasonable. We could be saving, right? We could be saving money instead of paying off a loan, right? And so I think, was it on test 2 that she was going to Mexico, or was it the practice test 2 where, you know, she's saving money. We could do that on a regular basis, saving money. And then her grandparents gave her some money at the end, right? And then how much money did she have? That's the same problem, just going the other way, right? And so there's a couple of ways that this thing is going to change, but it's not going to change majorly, right? So it's the same structure. Any questions about that one? Okay. All right. I'll start this on a new page. How about question 2, or I guess the short answer is question 1. So technically question 3, or question 2. Ted purchases a plot of land for $200,000 with a 15% down payment. He then makes end of the year payments for the next 18 years to pay off the property. Assuming that interest is 3% compounded weekly, what are Ted's payments? Include a timeline in your answer. So of course you have to have a timeline regardless of if you're using your calculator or doing it by hand. For completeness sake, I'll do it both ways because doing it on your calculator is going to be really kind of quick. So because it doesn't say that you have to do it by hand, right? You're allowed to use your calculator. For that reason, I'm going to start and just do the timeline, right? Because the timeline will be the same regardless, and then I'll show you the different ways that we could solve it. Okay. So here today, he buys this plot of land and he's making payments for 18 years. He then makes end of the year payments. So let's just highlight end of the year payments. And interest is compounded weekly. If we're doing it by hand, we're going to have to find I2, right? Because yearly and weekly are not the same, so we have to adjust that. If we're doing it on our calculator, we don't have to find I2 because it does it for us, right? So for 18 years, and because these are yearly payments, right, we just got to take out 1 year, 2 years, up to 17 years. We want to find out what the payments are, right? So we just denote it as PMT because that's what we're solving for. And these are end of the year payments. So our first payment is here at the 1 year mark. And then our last payment is at the 18 year mark. Again, right, these payments could be at the beginning of the year or beginning of the month or whatever. And again, the alternative for a future value would be he's saving this amount of money, right, instead of paying off a loan. But because we're paying off a loan, these guys all funnel back to a present value. And we know that, okay, so the total purchase was $200,000. But then he makes a down payment of 15%. So the present value is going to be the 200,000 minus the down payment. Right? Or alternatively, we could say the present value plus the down payment. That total has to be 200,000. And the down payment, oh, it's really hard to see there, isn't it? The down payment I'll just say down is going to be the 200,000 times 15% times 0.15. So 200,000 times 0.15 is 30,000. Oops. So the present value plus 30,000 has to be 200,000. And so therefore, the present value has to be 200,000 minus 30,000. So the present value is 170,000. Because you can't have two unknowns, right? But given the total and the down payment, we can figure out what the present value is, and then we'll be able to solve for the PMT. Now our N here is time times the frequency, the payment frequency, right? And so time is 18 years times 1, which is 18. Okay. So here, all right, this is more, I guess I should draw it in a different color. We will first solve this by hand. Right. And then I'll show you how to solve it on your calculator. I think you might prefer your calculator, but I'll leave it to you. Yeah. So if we're solving this by hand, because this is the timeline regardless of how you're going to solve it. Okay, so if we're solving it by hand, we know our compoundings per year is weekly, so 52. And our payments per year are yearly, so 1. So F1 is 52 and F2 is 1. So we need to find I2, right, because these are not the same. And so I1 is R over F1. And that was 0.03 divided by 52. 0.03 divided by 52 is 0.000576923. And I'll just make a note that I'll store this in 1. 1 for I1, maybe. Now I can find I2. I2 is 1 plus I1 to the power of F1 over F2 minus 1. Because I've said what I've stored in 1, I'm just going to use recall 1. 1 plus recall 1 to the power of 52 over 1 minus 1. So plus, oh, actually, 1 plus recall 1 to the power of 52 and then minus 1. 0.03044562, which I'm going to store in 2. 2 for I2. You can check in, right? Because now you know I2 should be compounding annually, and so it should be really close to 3%, right? 3% compounded weekly, 3% compounded annually, right? Or 3.044. Store that in 2. All right. So now, to solve for the payment amount, this is just an ordinary annuity, right? So it's not a new annuity due. If it were, we would pick the other formula, right? But it behaves the same way. So now, sorry about the sun there. So now, to solve for the PMT, right, we're going to use PB, which we know, which is our PMT times 1 minus 1 plus I to the negative n all over I. Our PB, we decided, was 170,000. So 170,000 is our PMT, which we're solving for, times 1 minus 1 plus recall 1, 2. 2 to the power of negative n, which is negative 18, over recall 2. So again, starting inside the little brackets and blooming out, right, we've got 1 plus recall 2 to the power of 18 negative, 1 minus that divided by recall 2, I get 170,000 is the PMT times 13.70183957. solving for PMT, I get 170,000 divided by 13.7. So 170,000 divided by that guy, I get 12,407.09316. So in dollars, 12,407.09. Or you can use your calculator. Or did I use a light green or a dark green? Or we could solve using the calculator. What would that work look like? I usually list them from top to bottom, right? But now in order to save a little bit of space, I'm going to write them from left to right, right? But I have to list all my calculator inputs, right? And so I'm going to start here with N, interest per year, present value, PMT, future value, payments per year, compoundings per year, and beginning or end. And in the test, if you've forgotten what all these are and the calculator is not helping for some reason, then they're on the front page of the test, right? So I have listed all these on the front page of the test, so you don't have to memorize them or anything. They'll just kind of flow. But also you could probably just steal them from the short answer section if you wanted to, okay? All right. Now we need to figure out what values go where, right? And so we said we have 18 for N. Our interest per year is 3. Our present value is 170,000. Now, how I want you to think of a loan is that's money to you, right? Despite you spending it on a house or whatever, right? From the bank and you, right? That's money to you. So this is going to be a positive 170,000. We're solving for our PMT, so you have to denote that with a star. Once you're done paying this off, right, the future value is going to be 0. Our payments per year is 1. Our compoundings per year, 52. And we're at the end, so we have to be in the end mode. All right, so you just want to make sure that you're in the end mode. And now we just plug them in. 18 for N, 3 for the interest per year, 170,000 positive for the present value, 0 for the future value, 1 enter for the payments per year, right? Remember, you have to hit enter after your payments and the compoundings. 52, enter, and just double check that you're in the end mode. Now, if I go back and I compute the PMT, I get a PMT equal to negative 12,407.09316. Therefore, PMT in money is 12,407.09. It makes sense that it's negative, right? Because these are payments that you're making, right? So it's money leaving you. I'll leave it to you guys to decide which way you prefer. But this gets you the same amount of marks as this. So it's up to you. But you arrive at the same answer, right? So it has to be negative because you're making these payments, right? And so it's just a notation for which way the money's going. Because if this was positive, right, then that would say that you're borrowing $12,400 every year on top of the $170 that you've already borrowed. Right. Any questions about that one? Yeah. Error 1. Usually, I think that's if it's positive and negative, but it should be fine because you use the positive present value and then your future value has to be 0, right? Maybe start and we can have a look later. Yeah, because we'll want to get that sorted out. All right. Put this on a new page. All right. You currently have $30,000 in your RRSP. You currently have $30,000 in your RRSP. You're going to let it collect interest at a rate of 4% compounded weekly. Okay. You will let it grow until it can sustain month-end payments of $500 forever. Forever. While money earns 5% compounded weekly. You'll want to keep track because you've got a different interest rate for each section, right? And so how long will you need to wait until you start receiving the payments? I think we did one of these last day, right? And so, but I don't think the interest rate changed last day. I think it was the same, but that's okay, we can handle it. So what I'm gonna do is I'm just going to make the timeline first, right? Kind of keep my information separate here. And so I start today and I'm gonna let it sit for some amount of time, some unknown amount of time, until it can sustain month-end payments of $500 forever, right? Forever is a perpetuity. And so that's why I've got the arrow at the end to indicate that, hey, this is actually going to keep going and going and going forever. So at the end of each month, so from, bless you, from whatever point that is where it starts, right? We've got 1 month, and then we've got 2 months, and it just keeps going and going and going. Remember, for a perpetuity, I just want to see the first 3 ticks, right? The starting point, and then 1, 2, and then it just keeps going. We need to have payments of $500 in month-end payments. And so of $500. So the first one is at that 1 month mark, and then the second one's at the 2 month mark, etc. And so here, these $500 monthly forever is going to trace back, and because it's at the end of the month, and it could just as well be at the beginning of the month, right? Then it's a perpetuity due, right? But here we've got a present value of a perpetuity. A perpetuity doesn't have an N because it goes on forever, right? And so we don't need to have an N, but I am going to make a note here that the rate, the interest rate here, R1, let's call it, is 5% and F1 is weekly, so 52. Mixing things up here, I guess. No, I should keep the same notation. Sorry, guys. Our compoundings per year is 52, which is F1. Our payments per year are when we're monthly, so 12. Which means that we're going to have to figure out what I2 is for the perpetuity. And we'll probably have, oh, there's no payments for the second portion, or I guess the first portion, because it's just sitting there. It's a compound interest problem. And so what we have, right, is we have $300,000, we wish, 30,000, sorry. At 30,000, we're going to sit there until it grows to the present value of the perpetuity, which we don't know what it is, but we'll be able to solve for it, right? And so this is another one of those situations where we start on the right-hand side and we work our way backwards, right? And so this 30,000 is going to grow to a future value, which has to be equal to the perpetuity. And because we want to figure out how long this is, we've got n is question mark. Here, our r is 0.04, and our compoundings per year is weekly. Ha, just making mistakes left and right. Weekly is 52. We will be able, or we could use our calculator for this section, but not for this section, right? Because it can't handle perpetuities. So for that reason, and because it's not really worth it to use our calculator for just these compound interest problems, I'm just going to do it all by hand. But you could check your work using your calculator. Right? You're allowed to use your calculator, but I'm not sure it's worth it. So if we're mapping out how we're going to solve these things, right, the perpetuity is the first thing that we have to solve for, right? And so we can find the present value of the perpetuity is our PMT over I, right? But since F1 is not equal to F2, we first need to find I2. Okay. So we did perpetuities last day, and they're just kind of these fun things. So I1 is going to be R1 over F1, which is 0.05 over 52. Oops. 0.05 over 52 is 0.000123, yeah, 961538, which I'm going to store in 1. I2 then is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus, I'll cheat, recall 1 to the power of, oh, come on, 52 over 12, then minus 1. I get I2 is equal to 0.0041733349, which I'm going to store in 2. Now, because I know my PMT has to be 500, I can find the present value of the perpetuity. $500 over recall 2 I get 119,807.8565. So in terms of money, we have 119,807.86. So now the question is, how long is it going to take for 30,000 to grow to 119,807.86? How long will it take for $30,000 to grow to 119,807.86? Here it's just compound interest, right? So that's back to the front page because there are no regular payments, right? And so, and you've got a formula for n. Remember, we have to solve for n before we can solve for t. And so we know that n is the natural log of the future value over the present value over the natural log of 1 plus I, where I has to be that interest rate over F, right? 4%, so 0.04 over 52. Where I is R over F, 0.04 over 52, so I is 0.00076923, which I'll store in, I don't know, 3. So now, because this was kind of a detour there, n is the natural log of our future value, which is 119,807.86, over our present value, which is 30,000, over the natural log of 1 plus recall 3. $119,807.86 divided by 30,000. Oops. And the natural log of that, I get n is going to be 1.38469191, which I'm going to store in, I don't know, 7, but that's just for me. Just somewhere out of the way so I don't mix them up. Over 1 plus recall 3, and then the natural log of that is 0.000768935, which, just in case, I'm going to store that in 8. So now I've got recall 7 divided by recall 8. So my n is 1,800.791742. That's how many compoundings it's going to take, but we can't have 0.79 of a compounding, so we always have to round up to the nearest whole number. So we would need equal to 1,801. Where n is the number of compoundings. Now n is time times the frequency, so n is 1801. We're solving for time times the frequency, which was 52. So t is 1,801 divided by 52, which is 34.6346158. So t is approximately 34.63 years. That's how long it's going to take for 30,000 to grow to the 119,000. And that's at that point, the 119,000 will be able to sustain payments of $500 at the end of each month, was it? Forever. Any questions about that one? No? Okay. Then let's do the next one. Oh. There. Okay. We did one of these last day, right? And as long as you kind of map out everything that you're given, and I would definitely use your calculator for these questions, right? Doing them by hand, it's possible, but it's very lengthy, and why? So definitely, I'm only going to show you how to use your calculator. And if you decide to do it by hand, then you can check your answers because they'll be the same. So Oscar had 44 years on Sesame Street where he put away money at the beginning of every month. Okay. We don't know how much that is, so I'm guessing we're going to have to figure it out. His RRSP and savings earn 7% compounded monthly. When he officially retires after 50 years, right, so he's only making payments for 44 years, but then he's going to retire after 50 years. Oscar will receive payments from an annuity earning 5% interest quarterly. That's a different interest rate. At the end of every biweekly period of $200 for the next 15 years. How much were Oscar's monthly RRSP payments? So here we've got 3 phases. He's making payments, and then he stops making payments and it just sits there. And then he's getting payments, getting payments, right? And so same idea as the previous question, we're going to cascade backwards, right? So move from the getting payments, figure out how much we would need at that point, and then we'll kind of trace it back until we're able to solve for the payment amount. All right. So these problems are going to look something like this, and you're going to need to have a really good timeline. Otherwise, it just won't work out. I can guarantee it. So we'll start today. And then we know at some point after 44 years, and I'll put the 44 years up above because he's making payments at the end of every month. Right, so those ticks are going to be monthly ticks. Then, between the 44 years and the 50 years from today, right? It's just going to sit there and earn interest. Right? So here at the 50-year mark, is another kind of stop and go situation. And then he's going to get payments for 15 years after he retires. So from today, that's at 65 years. Right? Because this distance, we're told, has to be 15 years. And we know that between 44 and 50 years, that's 6 years. Yeah, many things. Okay. And then, of course, between today and 44 years, that's 44 years, but that's not really too useful. We've got that one under control. All right. So he's making payments at the beginning of every month. So we've got monthly payments, so 1 month, 2 months, ... 44 years, there's 528 months. So the one before that is 527 months. And there's going to be unknown payment amounts, but these are at the beginning of every month. So how we show that on our timeline is we shift all our payments to the beginning of that payment period. And so we've got a payment today, a payment at 1 month, 2 months, and then our last payment is at the beginning of the 528 months, so that we put that at the 527 mark. There. So that's how we show that those payments are actually at the beginning of each month. So these payments are going to funnel to the 528 month mark, right? Because they go all the way to the end, right? And they become a future value due. Due because these are at the beginning. And you have to show that on your timeline, right? You can't just say future value because that's different. It's a future value due. Okay. Then this future value due becomes the present value of where it's just sitting and earning compound interest, right? So this becomes a present value, which is going to grow to a future value. And here it's just compound interest. So on our arrow, we can say, okay, well, n is the number of compoundings. And so we've got time times the frequency. So n is 6 years times, and for this whole section, it's 7% compounded monthly. So for these guys, R is 0.07 and F1, or the compoundings per year, I forgot already, monthly, yeah, it's 12, which is your F1 if you need it. So 6 times 12, which is 72, right? 72 compoundings for that section. For our payments, we already decided that we have n is 44 times 12, which is 528. Okay. Then, okay, now he's going to receive payments at 5% interest quarterly, right? Compounding quarterly is what that means. At the end of every bi-weekly period for 15 years. So at the end of the bi-weekly periods, so now this first tick is going to be 1 bi-weekly, and I just use BW, 2 bi-weekly, and for 15 years times 26, there's 390 bi-weeklies. Remembering that that distance is only 15 years. So 390 bi-weeklies puts me at 389 bi-weeklies, and then dot, dot, dot in between. We need payments at the end of every bi-weekly period. So now these are $200 payments at the end. So that's going to look like that. This is basically where we start, right? Because these are going to funnel back to some present value, just a plain present value because they're at the end of the payment period. But that value is going to be equal to the future value of the compound interest section. And so what we're going to do is we're going to work our way backwards, right? We funnel these guys into here. Now we know how much this is, so we know how much this is. So then we can solve for this, and then we can use that because then that has to be that, and then we can solve for the PMT. What's the big deal, guys? So here on our arrow, we've got N is time times the payment frequency. So this is going to be 15 times 26, which we said was 390. And making note that here, our rate is 5% compounding quarterly. All right. So now it's just a matter of kind of tracing these things backwards. We don't have to use our calculator. I'm going to use my calculator. And what I want you to do is I want you to break up each of these sections into calculator sections, right? Because that's going to be the easiest way to organize your work. It's not hard enough for you guys. Keep chatting. All right. So like I said, I'm going to kind of separate these, I don't know, maybe with a yellow here. Not much room for my compound interest section. But you get the idea. So for each of these, you're going to have all your calculator inputs and interest per year, present value, PMT, future value, payments per year, compoundings per year, and if you're at the beginning or if you're at the end. Okay. So I'm going to start and I'm just going to set up all these empty calculator inputs And then we'll see how things pan out here. And interest per year. PV, PMT, future value, payments per year, compoundings per year, and beginning or end. And finally, I absolutely could just copy and paste, but I don't want to leave you guys in the dust if you're writing them out. Okay. So we're a little bit squeezed for our compound interest section, but it's going to be okay. All right. We've got different rates for each of these sections, right? So the first thing I'm going to do is I'm going to make a note to myself and just put in my different interest rates just so I don't forget. So my interest per year here is 5 and my compoundings per year is 4. Whereas for the next two sections, right, my interest per year is 7 and my compounding is 12 for both of these. So that's good. So now we've got those out of the way. We said that we'll start on the right-hand side and just kind of work our way backwards, right? And so for the first, or yeah, I'm going to call this the first calculation, right? We have N is 390. So we have 390 payments. Our present value is the one that we're solving for. So I'm going to put a little star there. Our payment amount. Now here's where it gets icky, right? This is where it's really important that we keep track of, okay, are we getting this money or are we putting this money away? So here, these are going to be payments that he's getting, right? So these are going to be positive. So $200 positive. By the end, there's going to be nothing left of it, of what he saved, right? And so the future value is going to be 0. He's got bi-weekly payments, so the payments per year is 26. And we said that these are at the end of the payment period. Okay. Now we can plug all these values in and we can solve the present value. Okay. So the 390 for N, 5 for the interest per year, 200 positive for the payment, 0 future value, 26 for the payments per year, enter, 4 for the compoundings per year, enter. And I'm already in end mode, so I'm all good. Compute the present value, and I'm going to use green or some other color just to denote negative 54,933.26678. That's money though. So in terms of what we'll use later, we're going to round that to 2 decimal places. And just to show where that value ends up, right, that's this value. And so that's going to be the future value in this next calculation. So the future value is 54,933.27. Is that positive or negative? If we think of it like this, here, he's making payments, those are going to be negative. So this one has to be positive. So the idea is he gets that, and then he puts it back in here. So that's gonna be negative. And then he takes it out, so that's gonna be positive. And then he puts it back in. You're gonna get the same answer, but it's good to have that kind of idea down. Right? And so here, if he took it out, put it in, took it out, this is gonna be positive. Right? For compound interest though, remember you just have to have opposite signs. Doesn't actually matter. Right? It's only when you have payments that it matters. Because the idea of you get a loan and then every month you get another loan and add those loans together, right? That's not going to work out. Okay. Our N for this little section we said was 72. That's our compoundings per year, right? Or that's the number of compoundings. So do you remember what we did for the payments per year for compound interest? We just let them be the same as the compounding, right? And so this is going to be 12. And it actually doesn't matter if you're in begin or end mode, but I'll just have it in end mode because it's, I don't know, feels safer for some reason. But because there are no payments, it doesn't matter. The present value is again the value that we want to solve for, right? Because we're actually going to be moving this way. So again, we're solving for the present value. And remember before we said if we don't have any payments, right, we just let them be 0. Okay. So now we can use our calculator again. 72 for N, 7 for the interest per year, 0 for our payment, 54,933.27 positive for the future value, and 12 for the payments per year, enter, 12 for the compoundings per year. Compute the present value. It's going to be negative 36,137.80086. Looking at our roadmap here, that's going to be our future value in the last calculation, right? So the future value here is 36,137.80, rounding to 2 decimal places. All right, let's think about if this is going to be positive or negative. Well, we said, okay, if we're making payments at the end, the idea is we take it out, and then if we reinvest it, that's fine, right? But that's a separate kind of transaction. And so the future value here, again, is going to be positive. Okay. And for this portion, we said was 528, right? Now we're back to payments. This is an annuity, so it's the number of payments. The present value, we started with nothing, right? There was no mention of, oh, he already had 10,000 saved away. Nope. He just put away money, started with nothing. The payment is the one that we're trying to solve for. Our payments per year is monthly, so we've got 12, and they were at the beginning of each month. Notice how I only have to look at my timeline to figure that out, right? And so that's what your timeline should be telling you, right? If it's at the beginning or at the end. So this, I have to change to begin mode. I'm actually going to start there because I'm always scared I'm going to forget. So second, and then payment button, and then second enter to change it to begin mode. So now 528 and 7 for the interest per year, 0 for the present value. Coming back to the PMT, 36,137.80 for the future value. My payments per year are 12. My compoundings per year are 12. I'm in begin mode already. That's good. Compute my payment. And I'll just use a different color. Negative 10.19137909. Therefore, his monthly payments must be $10.19. Hey, not bad. Huge interest rates, but not bad. Right. Any questions about that one? So you'll really want to master your calculator for that one. Right. All right. Now let's do the mortgage question. Or I should say amortization schedule question. They've all kind of dealt with mortgages somehow. You purchase a $570,000 home in Lake Country. You're going to make a 15% down payment and repay the remainder of the mortgage at a rate of 4.3% compounded semi-annually. Part A, calculate your beginning of month payment if your amortization period is 25 years. Okay. And so first thing I have to do is figure out, okay, well, how much am I making payments on, right? So I have to take my house value minus my down payment. And so the mortgage amount, oops, is going to be the 570,000 minus the down payment. Which is 570,000 minus 570,000 times 15% is 0.15. Which is 570,000 minus 85,500. So my mortgage is going to be on $484,500. That's going to be the present value of my loan. Right? So whether you want to draw this out on a timeline, you don't have to. It doesn't ask for a timeline, so you don't have to. I'm actually going to stick or go straight to using my calculator to find the payment amounts. So I've got N, interest per year, present value, PMT, future value, payments per year, compoundings per year, and beginning or end. Now my N is I'm making monthly payments, so 12 for 30 or 25 years, so times 25, I get an N of 300. Interest per year is 4.3. The present value, remember, if you're buying a home, you think of it as, okay, so you get this loan, that's money to you from the bank. They don't actually care if you spend it on a house or whatever. Well, they do, but in our scenario, we're going to say, oh, they don't care. You got the money, so it's positive. So 484,500. We're solving for the payment amount. Our future value, once we're all done, has to be 0, right? We're going to force it to be 0. Our payments per year, we said were monthly, so they're 12. And our compoundings per year is semi-annually, so 2. And these are at the beginning. So what we're going to find is our payment amount. So once we plug these guys in, 484, 500, 0 for the future value, 12 and 2, enter. Begin mode, compute, payment, I get negative 2,618.670959. So therefore, my payment amount must be 2,618.67. That answers that. Okay. The next part is, and I'm just going to do this little section first, copy, and then I'll go back and steal the table. The reason I'm doing that is because in order to work in the table, I have to find I2, right? Because the compoundings per year and the payments per year are not the same. And so we have to go out and find I2. So the compoundings per year are 2, which is our F1, and our payments per year are 12, which is our F2. So I1 is 0.043 divided by 2. I have 0.0215. And so I2 is 1 plus I1 to the power of F1 over F2 minus 1 plus 1 to the power of, so 1 plus 0.0215 to the power of 2 over 12, then minus 1. I2, I get 0.003551648, which I'm going to store in 1. That one's going to be really important, right? Because we need it for each of these lines. And so now that I have I2, now I can go ahead and do my amortization schedule. Sort of. Oops. We already decided that we have 300 payments, right? But we also know by the facts that we established last day that the first payment number is always going to be 0, right? And then I've told you that I want to see the first and the second payment. So 1, 2. You will only have room for one cell of dots, right? Because then I want to see the 115th and the 116th payment. But in order to get the 115th, I need to know the future value at 114. So 114, then 115, and then 116. Da, da, da. And then I want to see, there. Then I want to see the last two payments, which means, okay, well, I want 300, I want 299, but in order to calculate 299 completely, I need to know the future value at 298. All right. Remember from the facts that we established last day, the zero line, there's nothing going on except for the balance. That's the original value of the loan. So that's going to be your 484,500. We also said that, okay, we've calculated our payment amount. It's $2,618.67 for all of these, except for the very last payment. Right. Oh. So we have come on. 2,618.67 all the way down except the very last payment. Okay. We calculate the interest amount, right? That's an interest amount by taking the previous balance times I2. And so we've got 484,500 times recall 1. And I'm paying, for the first payment, I'm paying 1,720.77, always rounding properly to 2 decimal places in interest. I paid $2,618.67, which I'm going to cheat and I'm going to store that in 0 maybe, so I don't have to type it in every time. All right. Minus 1,720.77. So the amount of principal I'm paying is $897.90. So the remaining balance is going to be 484,500 minus that guy, which makes 483,602.10. And so the race is on, and we're slowly paying these off, or paying it all off in 300 payments. So then we take that times recall 1, which is your I2. And now we're paying a little bit less in interest. And every time we're going to be paying a little bit less and a little bit more towards the principal. And so we've got, I get 1717.58 in the principal, and then recall 0 minus 1717.58. Now I've got 901.09 going towards the principal, 483,602.10 minus that guy, 482,701.01. That's the first 2 payments. Now, in order to show the middle 2 payments, remember I have to find the future value after 114 payments, right? The future value is how much is left owing. And so we're not going to have any information to put in here, but that's okay. And just to show here, I'm going to do, come on, that calculation down here. This is the future value after 114 payments. So what we're gonna do, and it looks basically the same as this, except now we know what our payment amount is. So we're gonna put that in, and we're gonna change our N to 114, right? So our N, our interest per year, our present value, our PMT, our future value, our payments per year, our compoundings per year, and beginning or end. Anything that's not changing, you don't have to put in again, right? So our N, that's changing, that's gonna be 114, so I'll just highlight that because that's new, right, from before. Our interest per year is still 4.3, I wanna say. 4.3, that stayed the same. Our present value is still 484,500. Our payment, we're gonna enter, and remembering that we're making these payments, right, so they're gonna be negative 2,618.67. You have to round to 2 decimal places. That one's new from before. Our future value, oh, yeah, is the one we're gonna solve for. Payments per year is still 12, compoundings per year are still 2, and we're still in begin mode. Those have not changed. So the only ones that we need to go in and change is N and the PMT. So I'll start with the PMT, 2618.67 negative into my payment, and then 114 into my N. And now I can compute my future value. After 114 payments, I owe $357,280.7274. So in terms of the dollar amount up here, that's $357,280.73, rounding properly. So now you're going to use that value, 357,280.73 times, I2 is in recall 1, right? Yeah, times recall 1. Now I know the amount of interest for payment 115. And now we're basically back to the same situation that we had for the first 2 payments, right? So now we can just kind of plug away here. 1,268.94, rounding properly. And then recall 0 minus 1,268.94. I get 1,349.73. 357,280.73 minus that guy. Now I owe 355,931 even. Oh, guess it's not that weird, but it's a little weird. That times I2, 1,264.14. Recall 0 minus 126414. I said plus, and I did plus, that's why it didn't work out. Minus 126414. 1,354.53. Take away that from 355,931.00. I get 350. 354, 57647. Dot, 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 dot. We do the same thing. To find the future value after 298 payments. We're expecting it to be very close to just, it has to just be a few payments away, right? So that's your check-in point. And what's nice is that nothing in your calculator changes except for your n. And so the future value after 298 payments and interest per year, present value, PMT, future value, payments per year, compoundings per year, beginning or end. The only thing that changes is your n, 298. And then 4.3, 484, 500 minus 261867. Solving for the future value, 12, 2, beginning. Only changing my n, 298. Shh, we're so close. 298 for your n. Compute your future value. Sure enough, only a few payments away, your future value is negative 5228.582531. So the value that we put in here is 5,228.58. We can use that times I2 to solve for the amount of interest, 5228.58 times recall 1. Now we're only paying $18.57 in interest, and the rest is paying off our principal. And so recall 0 minus 1857, 2,610 pennies. That's getting chipped away from our balance. So now we have 5,228.58 minus that guy. I owe 2,628.48. Here's where things get different, right? I still have to pay interest on this. So I'm going to multiply it by I2 times recall 1. I need to pay $934 in interest, right? I have to pay that. But I also have to force this to be 0, which means that this amount has to be this guy, right? And so, wait, 0, and this has to be 2,628.48. So my final payment has to be the amount of interest plus the principal, because I have to pay both of those. And so 934 plus 2628.48, my last payment is 2,637.82. How can I make this more clear? Right, that's your final payment, and that's different. But that's okay, just because we have to square everything up. The last part of the problem asks, what was the total amount of interest paid on the mortgage? See if I can squeeze this down to one line. Well, the total paid, right, is all your payments. So your payment amount times 299 plus the last payment, because it's a little bit different. Take away what you borrowed. Everything left over is the amount of interest, right? And so the interest paid is the total paid minus original balance. The total paid is $2,618.67 times 299 plus the last payment, which was 2,637.82 minus the original balance, which is 484,500. Okay. I want to do 2,618.67 times 299 plus the previous answer. So I get 785,620.15 minus 484,500. So the amount of interest that I've paid is $300,120.15. Yikes. That blows. But you own your beautiful home. Any questions?
Can I see the last one again? The last one?
This.
Last payment.
Oh yeah, that one. All right, no questions? See you guys on Tuesday. I'll come back here, but I'm just gonna stop the recording.